Welcome to this live broadcast of Euclid, the launch of Euclid, a space telescope on its journey into darkness. I'm Matt Russell and I'm standing in the European Space Agency's Spacecraft Operations Centre. We're going to be tracking SpaceX and their Falcon 9 rocket flying out of Cape Canaveral in Florida. But more than that, we're going to be waiting here for the acquisition of signal. This is going to be when our little intrepid explorer, Euclid, is going to be sending us the first signs of life. And while we're anticipating that momentous event, we'll be talking to some brilliant minds, the engineers and scientists behind this mission. And it is an incredible mission. This mission is going to be delving into the dark universe, and that's all about dark matter and dark energy. So, as I said, I'm standing here in the main control room at ESOC, and I'm absolutely amazingly lucky to have right in front of me two gentlemen, two more brilliant minds. We've got Andreas Rudolph, who is the flight director, and he's been gracious enough to let us into his space at the beginning of this broadcast. And next onto his right, we have Tiago Luero, who is the deputy flight director, and he's going to be helping us with the launch, throughout the launch, and giving us flash updates from the main control room once I'm booted out. So welcome to the show, gentlemen.
Hi.
Hi. So, Andreas, we're about 40 minutes away from launch now. So, what activities are we up to in the main control room at the moment?
At this point, we have the mission control team A on console across the center in several control rooms. At this very moment, we're listening to spacecraft telemetry of our Euclid spacecraft sitting on top of the Falcon 9 rocket at the Cape. And just a few minutes ago, I've given the green light to my colleague Giuseppe Racca, who is the ESA Customer Launch Director at Cape Canaveral, and he has passed this on. It's one of the criteria for fueling the Falcon 9 rocket now, before launch.
Excellent stuff. Technical stuff, but excellent.
Thank you.
Tiago, Tiago, what preparations have we had in the main control room leading up to now?
Yeah, so my shift has been, my team has been on shift in the last hours until about an hour ago. We're preparing the ground segment, the ground stations, listening to the spacecraft telemetry to hand it over to Andreas to continue the final countdown, allowing him to do our traditional roll call.
The roll call. Now, the roll call is a very special moment. I know it's a bit of an iconic moment. So luckily, we've captured that as the iconic moment, and we can play it back now, I believe.
This is the OD on the briefing loop for the roll call. OM go. Some go. Systems go. AOCS go. Power go. TTNC go. Flight dynamics go. Project wrap.
10 minutes, I'm going to put that back on.
Project support.
Project support go.
Soft code go. Software support
Go.
S-track
go.
Computer
Go.
Comms
Go.
Maintenance
Go.
Scheduling
Go.
Okay, this completes the roll call for today's Euclid launch. All ground segment and teams are green for launch. Thank you.
Iconic stuff, right? Before I get booted out, it's worth having a quick look up at these boards because they're really, really impressive. These are all the missions that have been controlled from this very room. So we go right before I was born, 1968, all the way across to JUICE 2023. And we go all the way to 2023. That's 85 missions as far as I can count. And there'll be one more, hopefully, tallied on the end there as well. So I'm going to leave these gentlemen. Thank you very much, gentlemen. I'm going to leave everyone in the room to get on with their jobs. Like I said, we're in Darmstadt, which is actually about 20 miles outside of Frankfurt, about 30 kilometers. Darmstadt is not only where they fly these spacecraft, but is also a sort of safety lighthouse as well. So there are other things that they do in Darmstadt, which is things like look out for space debris. It's of course a very important thing at the moment, and also things like near-Earth asteroids and things like that. So I'm making my way over to a new control room, the dedicated control room, which is for astronomy, and I can see my first guest already sitting there, Thomas Ormston. And I'm going to make my way over to Thomas. Thomas, you're a system engineer. You work here, of course.
Yes, indeed.
So tell us a little bit about, well, let's start with this room. What's special about this room?
Sure, so now we're in the dedicated control room for the astronomy missions. So JUICE will be the newest of those, but we also fly XMM Newton, Integral, and Gaia from this room. And if you think about where you just were in the main control room as like where a baby's delivered in the hospital with all the experts sitting there expectantly, this is what happens when you come home. You come into a room like this, and this is where we fly the spacecraft for the rest of its life. As long as it lives, we look after it from right here in this room.
And it really is a working room, isn't it? I mean, as we've been rehearsing, we've been hearing little noises in the background, and these are the little noises from our, our actual spacecraft that are out there flying, right?
Absolutely, yeah. We're seeing data from the other astronomy missions coming in right behind us here. And as I say, it's very exciting that there'll be a fourth one. Hopefully very soon added to the mix and joining us in this room.
Yeah, if you wonder who the guy in the background with the beautiful shirt, it's Tim. Great guy. Wave to and he is, there he is. He's actually flying the spacecraft.
Yeah.
So I've been walking around, I get lost quite often. This is a very big complex, isn't it? Lots of rooms, and they're full of people. So can you describe the sort of activity that we have here?
Yeah. So, I mean, this room here is just one of the rooms where we're flying satellites to the planets, to Mars, to Mercury. We've got missions going around Earth. In fact, a lot of them go around Earth and look down on our planet to help us in our day-to-day work. And here we are really the heart of controlling Europe's fleet. And that's not all we do. I mean, there's way more. We could talk for hours about what we do at ESOC and ESA, looking after space debris, planetary defense, space safety, some of the biggest topics challenging us, but also presenting us opportunities in space today.
Yeah, no, absolutely. So it's a hive of activity in the MCR, the room that we were in, the main control room. Why is it so quiet in here?
Actually, that's a really good thing that it's quiet in here. We try as much as possible to make things automated, streamlined, efficient. So if things are quiet, that means that everything's going well. It's when this room gets busy that you begin to worry, because that means that the spacecraft, like any toddler, has thrown a tantrum, and they do from time to time. And then the various engineers and people will come in here and work through the problem, troubleshoot it, and get the spacecraft back on its feet and doing what it's meant to do. But the fact that it's just Tim here today is a good sign that the other three missions are quietly waiting their new friend in space.
Yeah, so the 4 missions from this room, hopefully from the when will they take control in this room? Do you know?
So it'll be a few days. We do all the most critical activities first of all in the main control room, where we've got everyone in there ready to jump in at a moment's notice, all, as you saw, linked up so that we can talk to each other and discuss and work problems very, very quickly. Once we're satisfied that the primary bits of getting the spacecraft safe and stable are done, then we move from that room into here, and then starts a fairly intense process called commissioning, which lasts over months, where we go from something that's just stable to something that's really ready to do its mission. And that's a lot of hard work, but also very interesting.
Yeah, so you've worked here for 18 years, so would you encourage other people to come and
Yes.
work here?
I mean, absolutely. You can probably hear it in my voice. I absolutely love it. I mean, when they told me I was given the opportunity to fly spacecraft, I was jumped at the chance, and I'm not going to...
Next time I'm here, I need you to show me where they keep the stash of tea. That's my only problem.
Yeah, we have multiple stashes. It's all about redundancy and backups here.
Yeah,
so.
no, I've not found the tea yet. Thank you very much, Thomas. Always a pleasure to chat with you. We're going to have a closer look now at the Euclid mission and the purpose of the mission. So we're going to have a look at that on a video right now.
The universe is not what it appears to be. Visible stars and galaxies make up less than 5% of its total matter and energy. The rest consists of mysterious, invisible substances called dark matter and dark energy. ESA's Euclid Space Telescope is a mission to investigate this dark side of the universe. A display of innovative engineering, the 4.7 meters tall spacecraft carries 2 instruments that will examine visible and infrared light from distant galaxies. It's taken more than 3,500 people in 21 countries, working in more than 300 institutions and 80 companies to make Euclid a reality. This extraordinary telescope will observe around 6 billion galaxies, creating a 3D map of the universe spanning the last 10 billion years of cosmic history. The shapes of the galaxies and their distribution across the universe provide vital clues about the nature and behaviour of the dark matter and dark energy. Analysing Euclid's data will allow us to see the universe not like it appears, but more like it really is.
So I'm delighted to be joined by two of these brilliant minds that I promised earlier on who were instrumental in this mission. That's Elsa Montagnol, the head of Mission Operations Division, and Elena Mariano, who are the spacecraft engineering manager for the Euclid project. Welcome to the broadcast. I'm going to start with you first, Elsa. The whole mission is about unraveling the mysteries of the dark universe. Exactly what on earth does that mean?
Well, this requires a comprehensive study of the composition and evolution of the universe. And in order to do that, the mission will generate the largest, most accurate map of the universe ever produced, recording the distribution of galaxies in space and in time, looking at 10 billion years of cosmic time. This sounds like a lot. Mm-hmm. And this will help us understand the nature and the characteristic of dark matter and dark energy, which form 95% of the cosmos.
Yeah, 3D map that goes all the way back in time as well as being a map. Yeah, it was really amazing. So Elena, how on earth do you build a spacecraft that comes close to fulfilling that mission?
Yeah, so the most important part of the mission is inside the telescope. We have the two instruments, the NISP that is working in the near infrared and the VIS that is working in the visible, that during the observation will acquire a huge amount of data and images that hopefully will help the scientists to try to understand which is the nature and the structure of the dark energy and the dark matter. As I said, the two instruments are housed inside the telescope with all the optics that are needed for the observation. We have also the service module that is the platform that is hosting the onboard computer that is somehow the brain where the onboard software and the OCS software are running. The communication system, including the antenna for the communication with Earth and the transfer of all this data to Earth, and all the equipment that are in charge of the attitude and orbit control. So there are a common effort, of course. The core, the heart and the eyes of the mission are within the telescope, and somehow the control and the brain is in the platform.
Yeah, I mean it's so much to have to pack into a spacecraft, but we've just been seeing images of the spacecraft just behind you. It's a beautiful looking spacecraft as well.
Yeah.
You've managed to make it look good as well as perform as well.
Yeah, for sure, it's beautiful.
I'm going to get you back as well in the later parts of the program to go over how you actually really did get to build this spacecraft, because it's an amazing story as well. In the meantime, I'm going to ask people to come in with their questions. I'm asking questions, but you can join in at home too. So right from the comfort of your sofas, by sending me your questions using the social media and the hashtag #AskEaster, you can actually get these experts and many more as the program unfolds to answer those questions. So I've already had one. This is a question from Astros02231. Hi, Astros02231 on Twitter. This is a really simple one. Elsa, what's the reason behind the name Euclid?
That's a very good question. The mission is named after the Greek mathematician Euclid, who lived 300 years before Christ. He's the founder of geometry, and as this mission will look at the geometry in the universe, we felt it fitted to give his name to our mission.
Yeah, it's often with these things it's an acronym, but this time not. This time it's just about Euclid himself. Yeah, the geometry of the universe being the really important bit. That's what this dark matter, dark energy. We can't find out what it is without that geometry.
Yeah.
And people have been joking, I've seen online, about it being, it may find that it's non-Euclidean or something like that, but let's not worry about it. So, we thanks so much for joining us, Elsa. Eleanor, we're going to get you back as well. So we're going to get you back when we get to when we talk about building the spacecraft. So this is a major milestone of the mission that we're going to be talking about for the first time after launch, and that is the acquisition of signal. That's what we're going to wait for. That is our milestone for today. So our next guest is going to play a major role in making that happen, getting that signal from the spacecraft. And through the wonders of technology, we're going to go over and talk to them. They're the other side of the globe, way over in Australia. So let's see if we can get Susie Jackson, the manager of the New Norcia ground station, on the line. Hi, Susie. Welcome to the broadcast. I can see an absolutely beautiful dish behind you. So tell me how it is involved in the mission, and did you have to do anything special to prepare for Euclid?
Yes, g'day. So as you can see, New Norcia 1's behind me. That's a 35-metre antenna that we'll be using tonight to acquire Euclid. This is actually a reasonably routine because we'll be running this one with both New Norcia 1 behind the first acquisition. We'll be running this one with both New Norcia 1 behind me and also New Norcia 2, which is up on the hill, which is a small acquisition aid antenna, a 4.5-metre antenna, to make sure that make sure absolutely that we get the signal from Euclid as soon as it turns on.
So how are you able to give? Can you give us a rundown of how you actually track the spacecraft?
Yeah, so we start off using a wide beam antenna at New Norcia 2. So we're never quite exactly sure where the spacecraft is as it comes over the horizon. So we use an antenna that's got a nice wide beam in order to capture the signal from the spacecraft. At first, we're expecting the acquisition to be about 10,000 kilometres distant to us, which is in our book is extremely close. So we can use the small antenna that has a very large pattern, so we're able to see the spacecraft even if it's a little bit off course. And then once we've zeroed in on the spacecraft, we track in on the actual signal that the spacecraft is transmitting to us, and we're able to lock onto that, and then we're able to steer the large antenna behind me to get the very high gain on the spacecraft.
So it looks a very, very heavy dish, Susie. So how on earth do you move something like that?
It's actually the motors that drive it are actually only about yay long. They're actually quite small. It has to move at a whole degree from one side of the or one horizon all the way to the other 5 or 6 minutes. It's very fast when it gets moving. It's fantastic to watch.
Thank you, Susie, so much. But hang around because we're going to come back to you for more updates as we make our way through the mission. So good luck, Susie. So I've been joined here in the astronomy control room by none other than Pierre Ferrou, who is the mission manager. Sorry for butchering your name again. Welcome to the show, Pierre.
Thank you very much.
All right, so we've seen that this is like an enormous mission, and obviously there's so much involved with this. So can you talk about some of the sort of collaborations that you've had to make this happen?
Yeah, it takes a very strong, diverse team actually to build Euclid, and I can start with industry. The prime contractor, Thales Alenia Space, they have gathered a team of companies, many European industrial companies, and this team has basically built Euclid. We are talking about 140 industrial contracts. And a completely different type of collaboration and very strong partnership is the Euclid Consortium. So it's a network of institutes, agencies, and they have delivered the Euclid instruments, and they are at the core of the processing, the analysis, the scientific exploitation of Euclid data. They have basically set up a network of data centers. And one last type of collaboration. We are actually collaborating on Euclid with NASA, because NASA is providing some key pieces of hardware. They are providing one of its famous data centers, and also, of course, they are funding supporting scientists, US scientists. We work together with the European scientists to achieve Euclid goals. Huh? So as you see, it's really teamwork, and we are quite proud to say sometimes that collaboration partnerships, they are in the DNA of the European agency, and we are quite proud of that.
Yeah, absolutely. Yeah, it's you always see these big missions, lots of collaboration. It's fantastic to see. And talking of collaborations as well, we know that it's not a sort of one size fits all for launch vehicles. You know, just getting this thing into space, it isn't actually easy. And for this launch, we've got a Falcon 9 by SpaceX. So tell us a little bit about why that particular rocket was chosen.
Yeah, it was chosen in the second time because we had to change rocket. And you have to realize that changing rocket for a satellite like Euclid, it's not easy. And what happened is that after Russia's war on Ukraine, we had to find a new rocket. And we looked for a rocket that would be compatible with Euclid, would be available so to launch in 2023. And after careful consideration, we selected Falcon 9. It was actually meeting all our needs. And the thing I would like to emphasize, and I think it's quite important, is to realize it's a difficult task to swap rockets. And our project team, the teams here in the Operation Center, industry, and SpaceX, they managed in less than 1 year to do all the checks, all the preparatory work that led us to today, with Falcon 9, with Euclid on board on the launch pad.
Yeah, I mean, this thing took such a long time to build, and then suddenly you're changing rocket. And yeah, I think it's an absolute testament. I hear it a lot that you know, that's been an amazing piece of work, a proper solid piece of work. It's really good to hear, isn't it? Thanks so much, Pierre. I think what we're going to do is have a quick look on the activity in the main control room now and see what they're up to. Tiago, how's it looking in there?
Matt, so now we're in a bit of a waiting period.
Stay.
Waiting for the rocket to go, hoping for a beautiful launch, but the team now is waiting for the launch. And that's it from the MCR. Over to you, Matt.
So if you've just joined us, we are following the Euclid spacecraft launch, starting its million-mile journey to L2. There'll be more on L2 later on. I promise I'll tell you what that is. We're in the European Space Operations Centre, where the fleet of European satellites are flown and controlled by a large multinational team of scientists and engineers. We're going to go over to SpaceX when their broadcast actually starts. So I'm going to carry on talking to Pierre just for a little bit, and then when SpaceX are ready, we'll go over to them. So Pierre, if someone wanted to do your job, what would you say? What would you say to some young student somewhere?
I think go for it, because I've been working in ESA for more than 10 years now, and I'm still not bored about it. And really being in places like that now, we are launching a mission. I will be working on this mission for the coming years. It's just fantastic, meaning it's just a dream job. And I just encourage people to go for it. Yeah,
and you're quite new to the Euclid project?
Yes, only 1 year, and we are talking about missions where some people have worked more than 10 years, 15 years on it. But still, for me, 1 year, and I'm already excited about the mission.
Yeah. So I mean, what did you do before? Did you do any exciting missions before Euclid?
Yes, I was at ESA. I was on web, so only 1 year ago, and basically, it's very exciting to see Euclid, which is going to be really a survey mission. We are going to map 1/3 of the sky, up to 10 billion years in the past.
Okay.
It's just.
So we're going over to SpaceX now, and so now it's the start of the launch coverage, and we will be back in the lulls of the launch period, so to give you the science of the mission and talk to some people.
Deployed, and Falcon 9 has landed.
Hello, everyone, and thanks for joining us for our launch today. Falcon 9 is set to lift off from Space Launch Complex 40 in Florida just under 17 minutes from now. Our 243rd overall mission to date and our 44th mission of the year. My name is Jessie Anderson, and I'm an Integration and Test Engineering Manager here at SpaceX. And today we have a really cool payload on board the second stage. We're sending a space telescope for the European Space Agency to a Sun-Earth L2 transfer orbit, also known as the Sun-Earth Lagrange Point 2, which is nearly 1 million miles beyond Earth's orbit. This telescope's mission is to help answer the question...
Stage 2 LOX float has started.
To help answer the question, what is the universe made of, by exploring the cosmic mysteries of dark matter and dark energy.
Monday.com makes GANs great again. Yeah, you know what? I'm not going to say again, because they never were, and they're complicated.
The heaviest spacecraft that Falcon 9 has launched
contributions from the Euclid Consortium and NASA. In fact, over 3,500 people from 21 different countries were involved in making today's mission possible. After launch, Euclid will have a month-long commissioning phase while traveling to its final destination. After 2 months of performance verification, it will then be ready for its science operations to begin. ESA will need some time to process the data, but is anticipating sharing the first images with the public in the fall. In just a few minutes, we'll be joined by members of the ESA team to talk more about the mission, so stay tuned. At T-minus 15 minutes and counting, we're well into propellant loading on the vehicle. Both the rocket and spacecraft are healthy. Weather is green and looks great over there in Florida, and range is ready to support liftoff at 11:12 a.m. Eastern Time. We do have a backup opportunity tomorrow at the same time if we don't lift off as scheduled today for any reason. Our Falcon 9 rocket and the Euclid payload rolled out to the pad from the hangar yesterday and went vertical a couple hours later. Now looking at the very top of the rocket is the payload fairing, or just fairing for short. And there you can see it on your screen. The fairing is made up of 2 composite halves that come together to encapsulate the Euclid payload in order to protect it from aerothermal loads, heating, and contamination during ascent. Now you might be able to tell that the fairing halves supporting today's mission are brand new. Once we reach the vacuum of space, the fairing halves will separate, and we'll attempt to recover them for potential future use using our recovery vessel, Doug. Now below the payload fairing is the second stage, which is responsible for taking our payload to its drop-off orbit in space. Today's launch marks the first mission for SpaceX taking a payload with a final destination of a Sun-Earth Lagrange Point 2 orbit. Right under the second stage is the inner stage, which connects the first and second stages together, in addition to housing the Merlin vacuum, or what we call the MVAC engine, on the second stage. The inner stage is equipped with pneumatic pushers that allow stage separation between these 2 stages during flight. Once separated, the second stage will continue on its journey in space, while the first stage will start making its way back to planet Earth. And speaking of the bottom 2/3 of the vehicle is what we're referring to when you hear the term first stage. You may also hear it being referred to as the booster. The bottom of the booster is equipped with 9 Merlin engines, and that gives us the 9 in the name for Falcon 9. These 9 M1D engines are used to accelerate the vehicle through the Earth's atmosphere and into various orbits in space. You may be able to tell by the soot on the first stage, but this is the primary part of the rocket that gets reused multiple times. The first stage supporting our launch today is flying for its second time, having supported the AX-2 mission just about 6 weeks ago. After liftoff and stage separation, we'll be attempting to recover the booster using our drone ship, which you can see there on your screen, a shortfall of Gravitas, which is currently stationed in the Atlantic Ocean. With liftoff currently set at 11:12 a.m. Eastern Time, let's learn a little bit more about today's mission. Euclid is SpaceX's first mission to a Sun-Earth L2 transfer orbit, also known as the Sun-Earth Lagrange Point 2. The Sun-Earth L2 transfer orbit is nearly 1 million miles beyond Earth's orbit and a most ideal orbit for space-based astronomy because telescopes in this orbit, like the James Webb Telescope, can keep the Sun, Earth, and Moon behind them while being close enough to transmit large amounts of data to Earth and receive solar power from the Sun. Now, in order to get the rocket and payload into any orbit, the rocket has to not only go up really fast, but it also has to go sideways. As we ascend, we tilt the engines, and that turns the rocket horizontally. To help demonstrate this concept, imagine firing a cannon from a really high mountain. The cannonball will arc, and then good old gravity will pull it back down to Earth. As you increase the power, the cannonball will arc and land farther and farther away. Eventually, if you could continue to increase the power, the cannonball will end up in free fall around the Earth. Basically, gravity is pulling down on the cannonball, but it's going so fast that it never hits the ground. This arc that constantly misses the Earth is called an orbit. Falcon 9 effectively does the same thing as the cannon in this example. It provides enough power and horizontal velocity to the spacecraft on board the second stage that the spacecraft is placed in orbit around the Earth. You'll be able to see this today by watching the orientation of Falcon 9 after liftoff. The rocket will go straight up until about T plus 10 seconds.
Internal power.
At which point we begin that shift in orientation by gimbaling the engines so Falcon 9 can go horizontally really fast. So be sure to look out for that after liftoff. With about 7.5 minutes left until liftoff, we are joined by NASA's Megan Cruz and ESA's Director General Joseph Oshbacher over at Kennedy Space Center in Florida. Hey, Megan, how's it looking over there on the East Coast?
Hey, Jesse. Welcome, everyone, to Florida and NASA's Kennedy Space Center, where just behind us, we are waiting to see Euclid launch on a Falcon 9 rocket right off the launch pad behind us. As you said, joining me this morning is Joseph Oshbacher, the Director General of the European Space Agency. Good to have you here this morning.
Glad to be here every time.
Yeah, I love that you're here. And yeah, just talk to us about how Euclid's launch that we're about to see in a few minutes comes on the heel of a great year for you guys at ESA.
ESA had really a fantastic year. We just came out of a ministerial conference in November last year, plus 17% more budget, many new projects, many new activities, so quite fascinating. We have selected 17 astronauts. Some of them will fly from here into space. We have just signed an agreement with Axiom. We're having 5 astronauts in training right now at the Astronaut Center. We have launched JUICE earlier this year. JUICE is an amazing mission which fits very well with Euclid, which is looking at habitability of the icy moons of Jupiter, something quite unimaginable, just as crazy as Euclid, dark matter, dark energy, which is really amazing. So we have a lot to do. We have a Space Summit coming up towards the end of the year, where we want to raise the profile of space in Europe to top-level politicians and to see what Europe needs to do to really be a strong space power, also to our partners in America.
Right, and in order to foster that, the space industry, I mean, one of the reasons you really want to do that is to also address a global issue that we here at NASA really care about as well.
Oh yes, we do. We have many satellites that look at our planet. Climate change is the largest problem on our planet for many decades to come, if not centuries, and we need to do everything we can from space. We have the Copernicus program, we have Meteor program, we have just launched MDG-1 last year, fantastic images that just came out, and we really make sure that we use our space assets to the best of humankind, and climate change is one of our big concerns. And one element which we just launched is not only on ground that we want to see at climate change, also in space. And I'm about to really initiate a zero debris charter where we would like to encourage people worldwide to not pollute our orbits. That means if you put a satellite up, you put it down at the end of its lifetime, and that's a new initiative we are doing.
Great. And any words for all the scientists that are hoping to really learn a lot from this Euclid mission?
Oh, the incredible science will come out. I'm pretty sure some Nobel Prizes will be won based on this data. This is really a fascinating mission. I'm so happy. I thank my community, my member states, industry, NASA also as a partner, and all the contributors to this. And thank you so much for this contribution.
Well, congrats to you, and I can't wait to see Euclid launch.
Thank you.
Thank you so much. Back to Hawthorne.
Thanks, Megan. We are about T-minus 4 minutes and 40 seconds away from liftoff. And at this point in the countdown, the clamp arms are going to begin to open up beneath the fairing, and then the transporter erector will begin to retract away from the vehicle in preparation for launch.
Retract has started.
And there we heard that call out. And you can see the clamp arms just below the fairing there on your screen. Those should begin to open shortly here. Once those are fully open, then the transport erector, or what you heard called the strong back, will retract away from the vehicle. And there you can see the clamp arms opening up there. Again, once those are fully open, the TE will begin to slowly retract away from the vehicle. And it is very slow and slight, but the TE is now beginning to move away from the vehicle. At this point in the countdown, both the first and second stages are nearly fully loaded with 1 million pounds of kerosene fuel and liquid oxygen. Both first stage and second stage should finish prop loading about a minute apart from each other. First stage finishing up at T-minus 3 minutes and second stage at T-minus 2 minutes. At T-minus 60 seconds, Falcon 9 will be in startup. Now, what that means is the rocket's autonomous internal flight computers will have taken over the launch countdown. Just inside of T-minus 2 seconds, we light the Merlin 1D engines for liftoff. The Euclid payload continues to be healthy, and the Falcon 9 team is tracking no issues on the rocket. Currently, both the vehicle and payload are healthy.
Stage 1 LOX flood is complete.
And we're looking good for an on-time liftoff at 11:12 a.m. Eastern Time. So let's send it back to Megan over there in Florida.
Hey, Jesse, you can start to feel the energy here at NASA's Kennedy Space Center. We're just behind us. We are waiting to watch the Euclid spacecraft launch atop of Falcon 9, again, on the launch pad right behind us. So with me now is Carol Mundell. She is ESA's Director of Science. Really great to have you here today.
Hi, Megan. Great to join you.
So talk to me about why studying dark matter, dark energy, why is that so important to understanding our universe?
Yeah, sure. This is one of the biggest unsolved problems in modern physics. So we actually think we understand only 5% of the universe, with the matter that we see, galaxies, stars, planets, ourselves. So 95% of the universe, dark matter and dark energy, is still a mystery and enigma, a huge frontier of modern physics that we hope this mission will actually help to push forward.
So then how do you go about detecting things we can't see?
Yeah, it's a great question, and of course this sense of darkness really comes from the fact that dark matter does exert gravitational pull, so we see the effect of it. We look at galaxies and they spin too quickly for the number of stars and the amount of gas they have. We look at the clusters of galaxies in the universe and we see too much mass. And so we don't know what fills that mass. It might be exotic particles, it might be that we've got our equations wrong. And on top of that, our universe is expanding. But the really big mystery for modern physics is that that expansion is accelerating. So it's actually getting faster and we don't know why. Our equations don't tell the whole story. And so what this mission will do is it will map all of that out to 10 billion years back in history and hopefully tell us the answer to the mystery of life, the universe and everything.
So then really quick, when do we expect to get this data back to start really analyzing it?
Yeah, so this is a 6-year mission, and the first 3 months of the mission will actually be calibrating the data because this is a huge feat of engineering technology. We have very, very precise images across all of the extragalactic sky, and then scientists around the world, we have 2,500 scientists in Europe and in the US across 9 data centers, will analyze these data all the way through 6 years. So our final cosmology answers will come at the end of the 6 years, but we'll do lots of exciting science along the way as well.
Carol, thank you so much. Very exciting.
Thank you.
Thanks, Megan. Thanks, Megan. We are just under 1 minute. Falcon 9 is in startup, and we are just waiting for the final go for launch.
LD, go for launch.
And great news. All systems are go for launch of Falcon 9 and ESA's Euclid Space Telescope.
T-minus 30 seconds and counting. T-minus 15 seconds and counting. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Into ignition, liftoff.
Stage 1 propulsion is nominal. Vehicle is pitching downrange.
Falcon 9 has successfully lifted off from pad 40 and throttled down to prepare for max Q, which is coming up at T plus 1 minute.
Power and telemetry nominal.
1 minute and about 12 seconds. Max Q is the highest amount of aerodynamic pressures. That's the largest structural load that the vehicle will see on ascent. We throttle down those engines just to pass through max Q, and then we'll throttle them back up once we pass through that period.
Falcon 9 is supersonic. Maximum dynamic pressure.
And great news, we have passed through max Q. You're getting some excellent views there on your screen. Next up, we have a few events happening back to back. That will be MECO, stage separation, and SES-1. MECO is main engine cutoff, and that's where we'll shut down all 9 of the M1D engines to slow the vehicle down in preparation for its next event, which is
MVAC chill has started.
stage separation. And that's where the first stage separates from the second stage. Right after stage separation, the first stage will begin its journey back to Earth for landing on our drone ship, a shortfall of gravitas. And during that time, stage 2 will continue on its journey with that third event, SES-1, or second stage engine start 1. And that is where the single Merlin vacuum engine will light up and propel the second stage along with ESA's Euclid spacecraft to orbit. In addition to these 3 major events, the fairing halves will separate less than a minute after SES-1, so keep an eye out for all of those events coming up here in just about 15 seconds or so. Again, coming up, we have MECO, stage separation, and SES-1.
Main engine cutoff. Stage separation confirmed. MVAC ignition.
Some really cool views of MECO stage separation, and on your right-hand screen, you can see that the MVAC engine has ignited.
Both vehicles are following nominal trajectories.
On your left-hand screen, the grid fins on the first stage are deploying, and in about 15 seconds or so, we should have fairing separation. And a very cool view from the ground.
Fairing separation confirmed.
And there you can see on your right-hand screen that the fairing halves have deployed. Now, as I mentioned previously, both fairing halves are brand new and are now making their way back down to Earth and will be recovered by our recovery vessel, Doug, today. It is T plus 4 minutes into today's mission, and in order to complete today's landing, the first stage has 2 more burns left. Next up is the entry burn, and that's where 3 of the Merlin 1D engines will reignite. This helps to slow the vehicle down as it re-enters the upper parts of the Earth's atmosphere. Now, that entry burn is coming up in about a couple minutes from now, and that entry burn will last about 20 seconds long. And what you're looking at on your screen, on your left-hand side, is a view from the first stage vehicle, currently making its way back down to Earth, which you can see in the background. And on your right-hand screen is a view from the second stage, looking aft at our MVAC engine.
Acquisition of signal, Bermuda.
That entry burn is coming up here just about a minute and a half
Both
from now.
vehicles continue to follow nominal trajectories.
And good call-outs there. On the bottom of your screen, you can see the speed and altitude of each vehicle as well. And on your left-hand screen, you can see 2 of the 4 hypersonic grid fins that the first stage has. Those grid fins help guide the vehicle as it makes its way back to its landing zone. Again, today we are scheduled to land on a shortfall of gravitas, currently in the Atlantic Ocean, waiting for the first stage vehicle. And on your screen, you're getting a great view from the second stage with the MVAC there and the Earth looking amazing in the background. We're just about 20 seconds away from the entry burn on the first stage vehicle. You may see some white puffs on that first stage. That is nitrogen gas puffs for attitude control.
Stage 1 FTS has safed.
And there you can see the engines have reignited on the first stage on your left-hand screen. This is the entry burn with 3 of 9 M1D engines reignited. And you can see that those engines have shut down. That concludes the entry burn for the first stage. Now we do have one more burn for the first stage vehicle as it attempts to land on our drone ship, and that is the landing burn. It will just be a single engine, the center E9 engine reigniting, and that is enough thrust to help slow down the vehicle to enable it to touch down on our drone ship. Now during the first stage landing burn, the vehicle will be landing for its second time.
Stage 2 FTS is safed. Stage 2 terminal guidance.
The vehicle will be landing for its second time today, and just before the landing burn begins, we will also have SECO 1 on the second stage. That is second engine cutoff 1. That's where we'll shut down that MVAC engine on the second stage. This is the first of 2 burns for this mission, and that is coming up here in just a few seconds, followed by the landing burn about 20 seconds after that. There you can see that the MVAC engine has shut down and the landing burn has begun on the first stage vehicle.
Expected loss of signal, Cape. Nominal orbit insertion.
What an incredible clear view of Falcon 9 touching down on a shortfall of gravitas. This landing marks the second successful landing for this particular booster and marks our 204th overall successful recovery of an orbital class rocket, including both Falcon 9 and Falcon Heavy first stages. We also heard the call out for SECO 1 and confirmation of good orbit. So with confirmation of a successful second engine cutoff and first stage landing, we are going to be in a coast phase until just before the second relight of our MVAC engine on the second stage, which will be followed by payload deploy. So sit tight and we'll see you back here around the T plus 17-minute mark.
Expected loss of signal, Bermuda.
Fine then.
welcome back to the live webcast for the Euclid mission. If you're just joining us, liftoff occurred at 11:12 a.m. Eastern Time from Space Launch Complex 40 in Florida. After liftoff, we also had successful main engine cutoff, stage separation, ignition and shutdown of the second stage, fairing separation, and first stage landing. Now, coming up shortly, we'll have our second burn of our MVAC engine on stage 2 prior to payload deploy, which basically means that we will relight and shut down the second stage engine for a second and last time. Now, SES-2 is coming up here in just about 10 seconds or so. Again, SES-2 is second stage engine start 2, and then we will shut down that MVAC engine about a minute and a half later.
MVAC ignition.
There we heard that call out, and you can see on your screen that the MVAC has reignited. Again, this burn will last about 90 seconds, and it will be the last burn of stage 2 before we deploy the payload. As a reminder, the Euclid payload is still attached to the second stage at this point and will be heading to a Sun-Earth Lagrange point 2 transfer orbit. And that is about 1 million miles beyond Earth's orbit. Now we should have SECO-2 coming up here in a few seconds. That is second stage engine cutoff. Again, will be the conclusion of the second and final burn for this mission.
MVAC shutdown.
We've just had SECO-2.
Nominal orbit insertion.
There's that call out. We just had SECO-2 and confirmation of good orbit. So with successful second engine start and cutoff, we'll join you live to cover payload deployment in about 20 minutes. So we'll see you in a few.
Oh, don't look up. We need to get to the top. I'm sure we'll make it. I wonder what awaits us there? The unknown is frightening. Sometimes it's hard to choose the right path, but don't be afraid. You can always repeat. We learn from our mistakes. Sometimes it's hard to choose the right path, but don't be afraid. You can always repeat. We learn from our mistakes. Sometimes it's hard to choose the right path, but don't be afraid. You can always repeat. We learn from our mistakes.
Expected master signal, Brazil. Acquisition of signal, goodbye. Acquisition of signal, HBK, 26 meters.
Hello, I'm back. you go walking this morning?
I did, yeah.
Thanks for joining us once again for the ESA Euclid launch. We've had a great mission so far, and we have just one more major milestone left in our mission, which is payload deploy. Built and operated by the European Space Agency, or ESA, with contributions from NASA and the Euclid Consortium, the Euclid spacecraft will be operated from European Space Operations Center in Darmstadt, Germany. It will explore dark matter and dark energy, which combined is known to make up 95% of the universe as we know it, and create an unmatched 3D map of the universe with time as the third dimension by observing billions of galaxies across 10 billion years of cosmic time across more than a third of the sky. The deployment is coming up here in just a few seconds.
Euclid spacecraft separation confirmed.
And there you can see the Euclid payload drifting away from Falcon 9's second stage. With that confirmation, we'll bring today's webcast to a close. Today's mission marked SpaceX's 243rd overall mission to date and 44th mission of this year. We want to thank the European Space Agency for entrusting us with today's mission and all of you for joining us. If you're interested in following the Euclid mission further, tune into youtube.com/ESA for more. And be on the lookout for the first images from the Euclid telescope later this fall. Thanks for tuning in, and we'll see you again soon.